This is part 1 of our lesson on equation applications. So the examples that we're going to do today are just some applications of the different equations that we've been solving over the last week. So our first question says the pH of a substance can be calculated using the formula pH equals negative log H plus, where the H plus is the hydrogen ion concentration in moles per liter. Determine the pH of a substance that has a hydrogen ion concentration of 4.93 times 10 to the negative 7 moles per liter. Round your final answer to 1 decimal place. So you should have learned in grade 9 science about pH. pH measures how acidic or how basic a substance is. So when you have a chemical compound like hydrochloric acid, HCl, when it's dissolved in water, it becomes aqueous and the atoms dissociate. So you end up with hydrogen atoms and chlorine atoms. And then this measures how many basically hydrogen ions there are in your solution. So really all we need to take out of this is our formula for pH that says pH equals negative log and then whatever your hydrogen ion concentration is. So when I'm doing the first part of the question here, it says determine the pH if it has a hydrogen ion concentration of 4.93 times 10 to the negative 7 moles per liter. So this number here is my H plus, and what we want to do is calculate the pH. So I'm just going to take my formula, pH equals negative log, and then the square brackets, they don't have to be square brackets, but square brackets in chemistry are used to show concentration. That's just notation, so that's why I always use the square brackets. So I know that my hydrogen ion concentration is 4.93 times 10 to the negative 7. That is scientific notation because that is a very small number. The negative exponent tells me that it's a pretty small number there. So instead of having to write 0.000000493, we just write it using scientific notation. Okay, so I have that pH is negative log and then 4.93 times 10 to the negative 7. So when I go to do this on my calculator, if you see what you type in on the screen, you would just type negative, not subtract. You want to use your actual negative key. So negative log bracket and then 4.93 times 10 to the power of negative 7. My calculator doesn't work like that. I have to do the bracket first. So I would do bracket and then 4.93 times 10 to the power of negative 7. Close the bracket, then press log, and then make it negative. That's the way my calculator works. So I ended up with 6.307153081. So it asks me to round to 1 decimal place. Usually when we're doing pH, we do 1 decimal place. So that would be 6.3. So the pH is approximately 6.3. And then because this is an application question, you should write a sentence at the end. So I'm going to say, therefore, the pH is 6.3. Now, pH does not have a unit. It just is a number. That's all it is. And pH neutral would be a 7. Anything smaller than 7 is acidic, and anything greater than 7 is basic. So this would be slightly acidic, so not very acidic. I would actually think that that's probably about the range of blood, or sometimes milk is usually in a kind of low to mid 6. Okay, so the second question says determine the hydrogen ion concentration of a substance with a pH of 2.4. It says write your final answer in scientific notation rounded to 2 decimal places. So this time, instead of giving me the hydrogen ion concentration, they've told me what the pH is. So I'm going to take the same formula, pH equals negative log of our concentration. And instead of putting a number in for the H, we're now putting something in for the pH. So I have 2.4 equals negative log, and then our H plus. Okay, so my goal is to solve for H. So I have two things here. I have a log, and then I have a negative in front of that log. That negative in front of that log is secretly a -1. Now I have two options. I can either, because it's a log, I could bring the -1 up and write it as a power on my hydrogen ion concentration, or I could just divide both sides by -1. It is easier to just divide both sides by -1. So 2.4 divided by -1 is -2.4. And that now equals log of my hydrogen ion concentration. Now, when we say log and there's no base, it is secretly log base 10. Now, if I want to get that hydrogen ion concentration all by itself, I need to find a way to get rid of the log base 10. So to take the log base 10 to the other side, I would do the inverse operation, which is an exponent with a base of 10. So I would do 10 to the power of -2.4 is my concentration. Now I am going to leave that square bracket on it just because that is the notation for concentration. So 10 to the power of -2.4 is a very nice looking answer, but it specifically requested scientific notation. So I'm actually going to calculate 10 to the power of and then -2.4. And I get 3.981071706, and then I have this little -0.3. So this means it is approximately 3.98 times 10 to the power of -3. And then what that means as a number is that there would be 3 zeros in front of that 3 with a decimal after the first one. So it would be 0.0039810710706. But I'm just going to write it in scientific notation, which is what it asked me for. So this is 3.98 times 10 to the -3. Now, it did say in the question that concentration in this case is measured in moles per liter. So this is going to be in moles per liter. You don't have to write the moles per liter on your calculation. You just need to write it in your final sentence. So I'm going to say, therefore, the concentration is, I guess I could have said hydrogen ion concentration. I'm happy with just concentration. So is 3.98 times 10 to the -3 moles per liter. All right. So that's the end of example number 1. You can join me in the next video where we will take a look at example number 2.